So one of the biggest issues on the test had to do with drawing the Q line, which is really important because when you're doing a distillation problem, it's usually the first thing that you're going to do. So I'm going to do a little tutorial on that, but before I talk about that, I'll mention the term constant molar overflow, which the question said you needed to assume. So it's a simplifying assumption, and what it means is that the molar flow rates for the vapor and the liquid are the same at each stage in the column as long as you're in the same section. So that's why you're able to draw the column like this, where in the rectifying section you have L and V, which are constant, and in the stripping section you have L bar and V bar, and F coming in at the feed stage. So a good way to draw the stages in the rectifying section are just like this: L dropping through and V going up. In the stripping section, L bar dropping through, V bar going up. So the only thing that's changing at these stages is the composition of these streams, right? The only place where this isn't true is at the feed stage, of course, because you're adding F new moles at that stage. So at the feed tray, if we draw it, we know that we have L bars entering from the rectifying section, V bar moles entering from the stripping section, and we're adding F. So they're all mixing so that L bar drops and V also exits. But V bar and V aren't necessarily the same, and L bar and L aren't necessarily the same anymore. So Q is this helpful parameter that helps us make sense of it all. And it's defined as L bar minus L over F, or Q equals 1 plus V bar minus V over F. So, from the exam question, we are told that the feed is superheated, and on the feed tray, 1/3 mole of liquid is evaporated for every mole of feed. So let's draw the stage and do a balance. So we have F entering L and V, L bar and V bar, and for every F entering, 1/3 of F is evaporating, we're told. So far this is true, but drawing it like this is usually a good way to get confused because we're seeing this 1/3 F going up, so maybe we're just going to think, okay, so 2/3 F drops. But that isn't true, and it's a good way to get confused. So try to keep this here. A better way to sort of conceptualize this is to draw it like we were doing those CMO drawings. So this is the tray. We can start by drawing L and V bar like this. And a useful way to think about it is that everything is mixing sort of in a layer on the stage, and that everything has to leave as either a saturated vapor, like a dew point vapor, or as a saturated liquid, like a bubble point liquid. So we draw the mixing layer, and the feed moves through, and it's a vapor. So it's going to exit as a vapor, but it has to exit as a saturated vapor. So used to be superheated, and now it's saturated, so that extra heat is going towards this liquid here, which is already at its bubble point, so some of it is going to evaporate, and that's where the 1/3 F is coming from. So you see the 1/3 F isn't coming from the feed, but it's coming from the liquid, and that's, if you read the sentence carefully, that's what the sentence is saying. 1/3 mole of liquid is evaporated for every mole of feed. So that means this V bar is moving through unimpeded, so this is still V bar. And this L is losing 1/3 F, so this is L minus 1/3 F. And that means that L bar equals L minus 1/3 F. And V bar, or sorry, V, is the sum of all these. 1/3 F plus V bar equals 4/3 F plus V bar. So with the equation we have for Q equals L bar minus L over F equals L minus 1/3 F minus L over F equals minus 1/3. So that's how you have to find the value for Q. And then when you're drawing the Q line, the value for Q is different than the slope of the Q line, because the slope is Q over Q minus 1, which is minus 1/3, over minus 4/3, which is 1/4. And then to draw it, I'll do a quick drawing here. But if you're giving equilibrium data like this, you have to find ZF. And that's where it starts, ZF, ZF. And then you just draw the slope that you just found. So it's a straight line. In this case, it's got a slope of 1/4. That's slope of 1/4. And that is how you drew the Q line for the exam question. I think it's possible that some people got confused by the example question I went over, because maybe they were getting the opposite answer. So here's another case. This was from one of the tutorial questions I did. So it was a bit of a more difficult question overall, but this part is really similar. And what it's saying is 1 mole of vapor must condense in a column to heat 4 moles of feed to its boiling point. So this is the opposite scenario. So you see it's actually a subcooled liquid. So this is also almost a confusing way to put it, 4 moles of feed. So that's the same as saying 1/4 F of V must condense per F that you add. That's the same. So if we do this balance around a tray, if that's the tray and that's the mixing layer, then L drops through, V bar moves up. So we're adding F as a liquid now, so that means the feed is going to drop through as a liquid. But since it's subcooled, some of this vapor is going to be giving off some of its heat, which means it is going to condensate. So that's where the 1/4 F is coming from. This L, nothing comes off of it, so it's still L. This V bar is losing a 1/4 F. So this is V equals V bar minus a 1/4 F. And this represents L bar. Oops. Which is L bar equals L plus F plus a 1/4 F, which is 5/4 F. And then you find Q again with those equations, and you find the slope, and then you draw it. So there's only 3 more possibilities of what the feed could be, so I figured I might as well talk about all of them. Oops. So